folks, welcome to another set of Chemistry 1 video notes. Today we'll be talking about properties of matter and how we can use those to identify substances. We'll be covering standard C.1.1, C.1.2, and C.1.7. So first, what are physical and chemical properties? Physical properties are properties that can be observed without changing the identity of the substance you're working with. At most, you might have to take the substance through a physical change in order to observe a physical property. Some examples of physical properties are density, volume, mass, color, shape, size, malleability, ductility, boiling point, and melting point. Chemical properties, on the other hand, can only be observed if you change the identity of the substance. In other words, your substance must undergo a chemical change in order to observe a chemical property. Some chemical properties are pH, which tells us whether it's an acid or a base, toxicity, which means is it toxic to living organisms, radioactivity, does its nucleus release particles, reactivity, what other substances does it react with, and combustibility, will it catch fire? There are two types of physical properties, extensive and intensive. Extensive physical properties change depending on how much of a substance you have. For example, the mass, volume, total energy, heat capacity, and entropy will all be different if you have a small amount versus a large amount. We'll learn about heat capacity and energy stuff later, but for now it's really easy to picture this idea if we think about mass and volume. If you have a larger object, it'll have more mass and more volume. The mass and volume are dependent on how large my sample is. Intensive physical properties are constant for a substance, regardless of the amount you have in your sample. For example, the color, temperature, density, conductivity, boiling and melting points, and specific heat capacity will remain the same for a substance whether you have a small amount or a large amount. When we compare substances or try to identify substances, it's best to focus on the intensive properties, as they'll always be the same for the substance. Comparing the mass or volume of two different substances doesn't really tell us anything about them, but comparing their densities will. You've probably learned this before, but a pure substance only contains one type of matter, either an element or a compound. It does not have more than one type of element or compound in it. That's what makes it pure. If you'll remember, an element is any of the 118 elements we can find on the periodic table. And a compound is when we have some atoms of those elements stuck together with chemical bonds. For example, an element might be hydrogen, which only consists of atoms of hydrogen. But a compound might be water, which consists of two hydrogens and one oxygen in each molecule, all bonded together. As long as we only have molecules of water in the sample that we're looking at, it's still a pure substance because each chunk or piece is exactly the same as the next. A mixture has multiple substances mixed together. If those substances are evenly distributed throughout the mixture, it's considered homogeneous, and the properties we measure should be the same from any point in the mixture that we're measuring. If the substances in a mixture are not evenly distributed, different parts of the mixture will have different properties, so it's called a heterogeneous mixture. In order to determine if a sample of something is a pure substance, you can look at its various physical and chemical properties. The easiest to look at are density, boiling point, and melting point. You can easily find the book value, or what scientists agree is the correct value for those three properties, and then compare those values to what you found for your substance. If you still can't identify your substance at that point, you could try undergoing various chemical reactions to observe its chemical properties. However, if you can't identify a sample based on the physical properties, it's likely that you have a mixture. A big difference between pure substances and mixtures are that the intensive physical properties and chemical properties of a pure substance always remains constant. Those properties can easily change in a mixture depending on what substances and how much of each component are present in the mixture. So, short story, if you want to identify an unknown substance, take a bunch of measurements on it, find its values for various physical or chemical properties, and then go compare them to the various book values until you find a substance that matches those properties. Since testing for physical properties won't destroy your sample, it might be best to determine the physical properties first, and then move on to chemical properties only if you need to. Now, the fun thing about a mixture is that the components of a mixture aren't stuck together at all. We can add more of one substance and change the properties of that mixture, or separate the components out and get back to separate pure substances. The two most common ways to separate a mixture are by filtration or distillation. When we filter a mixture, either a solid, liquid, or gas, or a mixture of states of matter, we separate the big components from the smaller components. For example, when we make coffee, we pass liquid water, very small particles, through the coffee grounds, much larger particles, over a coffee filter. The filter allows the water to go through after it's picked up some flavoring from the ground coffee, but the ground coffee remains in the filter. We can separate gases or liquids from each other too, in a very similar process that we call chromatography. Distillation is also a great way to separate components of mixtures. This time, instead of using the different sizes of particles of each component, we utilize the differences in boiling temperatures. If you have two liquids mixed together, one with a much lower boiling point than the other, we can heat the mixture up just enough to boil the one component without boiling the other. The one component boils, turns into a vapor, passes through what we call a condenser tube, and then condenses back into a liquid in another flask. I do this often to make distilled water for our class. By boiling the water, the minerals and other junk that exists in our tap water get left behind, and the water vaporizes and transfers to another container and turns back into a liquid. You should have already had plenty of experience with density from 8th grade science, but here's a short refresher. Density is an intensive physical property. That means that any sized sample of a pure substance will have the same density as any other sample of that same pure substance. To find density, you measure the mass, measure the volume, then take the mass divided by the volume. This usually gives us grams per milliliter, or grams per cubic centimeter. We could do this with mixtures as well, but the density of the mixture will vary, depending on how much of each substance is in the mixture. To find the density of a solid, you just have to measure the mass and volume. For a regularly shaped solid, you could use a ruler and geometry to find the volume. For irregularly shaped solids, you place them in a graduated cylinder of water to see how much the volume level of the water changes. That volume change is equal to the volume of the solid. To find the density of a liquid, you can first place an empty graduated cylinder on a balance, zero the balance, and then pour whatever volume of liquid you'd like into it. This will give you the mass and the volume of the liquid at the same time. You could also place objects of varying densities in the liquid to see which ones sink or float. The density of the liquid would be somewhere between the least dense object that sinks and the most dense object that floats. As a side note, you may also remember that when you place an object in liquid, it will float if its density is smaller than the density of the liquid. And if its density is larger than that of the liquid, it will sink. We often use water for this particular experiment, which in most cases has a density of 1 gram per milliliter, or 1 gram per centimeter cubed. Since the densities of gases are easily changeable based on the temperature and pressure of the gas, it's not really practical for us to find their densities. For most substances, the solid form of the substance is the most dense of the 3 states of matter. Liquid is a little bit less dense than a solid, and gas is way less dense than either. This is not the case for water, since ice, the solid form of water, is a little bit less dense than liquid water. That's why ice floats when you have a glass of ice water. Well, that's all for today, folks. As always, if you have any questions, please ask.